Tell us about Burcin's galaxy.
Oh my God, yes. Because I was studying these black holes and galaxy relationship in my main research, basically observing all these spiral galaxies. But in one of those, in the background, they just see this interesting looking galaxy. And they suggested, are you interested in this weird galaxy? And I said, yeah, I want to do it. And turns out to be very interesting, extremely rare galaxy.
Okay, we're starting.
Okay, let's do it.
Yeah, let's do it. I'm so excited. I'm going to get my drink.
Okay.
Yeah, we can edit all this out. It's fine.
Let's.
I'm actually going to leave it in. I think, oh, this polar is really good. Okay, good afternoon, or good morning, sorry, good morning.
Good morning.
We are doing another Meet the Astronomers episode. I have an old friend and colleague here with me, Dr. I'm going to start like... Okay, let's start.
We can start with your story.
Let's do that again. Okay, Joseph for the editing. We're starting now. Okay, so I'm here in Dartmouth College on the border of New Hampshire and Vermont with an old friend and colleague, Dr. Burcin Mutlu-Pakdil.
Yes.
Did I say that correctly?
Yes, that's perfect.
Okay, super. Sorry, I'm so busy concentrating there. So you are an assistant professor here at Dartmouth College.
That's correct.
Which for people around the world, this is an Ivy League school. So it's one of the sort of elite education institutes in the world, which is phenomenal. And we are doing another Meet the Astronomers episode.
Yep.
And that's very exciting. We've been talking about this and giggling this morning because I've known you about 6 or 7 years.
Definitely, yeah.
And we are a member of the DELVE collaboration, which does observations of the Milky Way and galactic field around the Milky Way.
That's correct.
Looking for...
tiny galaxies.
Basically tiny galaxies and stellar streams to probe the gravitational potential of the Milky Way.
Yeah, that's correct.
It's super exciting. And that ties into your research, which we're going to get into. I have a world expert here in galaxy formation and dynamics, and so that's morphologies. And so that I've got a super interesting question for you later, so I'm very excited. So I'm going to talk about your office. I love your office. You have all these knickknacks. And we talked about this earlier when we were setting up the camera. Can you please tell me why you have so many furries?
So, because my husband and I did long distance for 8 years. So when I was doing my PhD and grad school work and other research, I had to travel, but he stayed in the same place. So during this long distance relationship, whenever we get together, he was bringing me one teddy bear. So over the years, I collected so many teddy bears. So these are the ones that I brought here to share with my students.
Oh, that's I love them.
Yeah, it definitely brings inviting atmosphere to my office.
It does. It's a nice atmosphere, actually. And I'm just noticing you have some flashing bats in the corner.
Oh my God, it is such a funny story that I can also share.
Yes, please.
So for some reason, my students call me Batman. And apparently I get so excited and sometimes bending when I talk about research, and they started me calling Batman because of my demands, I guess.
Oh.
So it became a little bit joke. I even have this Batman lamp.
Oh, you do? Look at that. Oh, that's fabulous.
Yeah, they gifted me this. So whenever I bring up about the papers that they need to write,
yes,
they tell me, oh, Batman signal is coming.
So I think I had these for my children. These are these moons that light up at night.
Yeah, exactly. But then they painted Batman symbol on the top.
I love that. It's actually really nice. So this is going to be a very nice interview because you're one of those astronomers who's got lots of sort of personality and all these other things going on. I love it. This is going to be really nice. So I obviously know you as a scientist, but could you just introduce yourself to our 3 people that watch the podcast regularly?
Oh, sure. Happy to. So I am Burcin Mutlu-Pakdil, and I'm originally from Turkey. and I have been in States for since 2009. I came here for getting high education in astronomy, and I love galaxies. I love universe, and I always wanted to use telescopes to explore the space.
Yeah.
So I was hoping to like reach the stars. I was admiring, as a young kid, I was admiring young stars. Now as an astronomer, with true telescopes, I can reach those stars. So I love that. Yeah.
That is lovely. That's actually going to be one of my questions about what inspired you. But did you grow up in the dark area, the dark skies?
No, actually, I am from Istanbul, which is one of the biggest cities in Turkey.
Yeah.
So it is just like New York, fancy lights everywhere.
Yeah.
So it is so hard to see sky, but it is not the city that and the view that I could see from the city inspired me. It was actually a random middle school assignment.
Really?
Yeah. So, you know, to any students out there listening, to any assignment that you think it's too much might change your world. Like usually. So that assignment was actually an English assignment, right? Our teacher wanted us to write an essay about ideal person. What's your ideal person? Who you want to become when you grow up? And I was thinking, as a middle school student, very humble. I said, I want to be the cleverest person in the world.
Very humble. I like that.
Very humble. And then I have an older sister, and I ask her, who is the cleverest person in the world? I want to write about that person. And then she said, I don't know, Einstein, maybe, check it out. And then I search about him, and as more I read about his life, I fall in love with the physics that he did.
Mm-hmm.
And then I wrote an essay, and after that essay, I started reading about more physics things, and it's more like, you know, in those ages, there's science for kids journals.
Yes, yes.
My sister started buying these kind of journals because she saw that I am interested in science, and in these journals, you always see black holes, monster of the universe, dark matter, mysterious matter, what's that?
Yeah.
All these buzzwords. And I was like, oh my God, I need to know. I want to be astronomer. That is how it started. And after that, I wanted to, in Turkey at the time, there wasn't much astronomy education. So I did a physics degree in undergrad. And then I said, I need to go get education in astronomy, and that's how I came to the States.
Oh, lovely. And you did your PhD in Minnesota?
Minnesota.
Yeah.
Yep.
God, that must have been cold.
It was so cold. Yep. I definitely experienced minus 25.
Oh my gosh. So let me get this right. You went from the banks of the Bosphorus to Minneapolis, St. Paul.
Yep. But in middle, I actually had a little bit diversion because I'm first gen, so I didn't know how to apply from Turkey. If you don't have parents or family members who is in academia, I guess you don't. It can be hard to know what kind of things you need to search, how to apply in a country that you never been in. So I actually applied to Lubbock, Texas.
Oh.
Because from college, my friend was there doing a PhD in math. So I just applied there because she was there, and I get in. And apparently at the time, Texas Tech University didn't have an astronomy. So I actually did biophysics.
Oh.
Masters.
That's how you started?
Yeah, I did my biophysics master, and I am quite clumsy person. So in the lab, I was pouring things very wrongly and destroying the experiment constantly. And my professor was saying, "You are right. You should do astronomy." Like it is. My biophysics might not be for you. And then I said, "Yes, I agree with that." So, but while doing master's degree in the States, I learned how to apply for grad school. And I finally find my advisor, and I went to University of Minnesota.
So the funny thing about that is, in our collaboration, in the Delve collaboration, I tend to go to the telescopes a lot and do a lot of the observing. And, clever people like you do the hard stuff. So if you're clumsy, I'll go to the telescopes and you do the.
But the good thing is, the telescopes that we use, right? They are so big and fancy. They don't really let us really touch it, right?
No, true.
So there's always a telescope operator, controlling what we are doing. We are not hurting any system. So I think we are safe from that angle.
Well, so I think you know this. I used to work at Cerro Tololo, and the main telescope we use is the Blanco 4 meter with a dark energy camera, and I helped install that.
Oh, wow.
And on the top ring of the telescope, there are 4 LED projectors, and we project light onto the flat field screen for the calibrations. And so there were times where I'd be hanging off the top ring, you'd be 50 feet in the air.
Okay, that's not something that I would do.
It's so much fun. I bet you'd love it. But you're right; those telescopes are pretty hard to break.
Yeah. If there's something fragile, I wouldn't go close to it. But from far away with the computers and stuff, I can do what it needs to be done.
Okay, yeah, you're pretty good at the mathematical modelling. I agree. So it says, how do you become interested in astronomy? That's one of our normal questions we ask our guests. So that's so exciting.
So that's all about because of a random middle school assignment.
Yeah.
Just changed my life.
Oh my God, that's phenomenal. So I sort of had the opposite experience. I grew up in Wales, and it was very dark there in the winter. And so when I was about 7, I'd look up and you could see the stars twinkling, or not in your office ceiling, obviously. You'd see the stars twinkling, and obviously the constellation shapes, and they were different colours because the night was so dark.
Wow.
And I thought, why are they all different? I thought stars were just these sort of white twinkly things. And of course, then so I said to my mother, why are they doing that? She said, well, I don't know. So she bought me a book and a small telescope, and I was like, my God, there's this world out there that's just phenomenal. And then, after that, it's downhill after that.
I think that's one of the... so when I was in University of Minnesota, I did my PhD, but I was using archival data. I never took my own data. When I was at University of Arizona for research, that was the first time that I went to a big observatory, real observatory, and actually see the night sky and shining stars. That was the first time experiencing that. It was life-changing, as you said. It is such a unique experience that no one can really describe, I feel like.
No.
It's such a...
Very personal.
Very personal thing. And unfortunately right now, I feel like as the technology goes better, remote observing happens, right? Meaning you don't need to go to the telescopes, observatories. You can connect with wherever you are. You can connect to these fancy computers and control the telescopes and get the data. So you really don't need to visit the observatories anymore nowadays. So I am a little bit sad about that, actually. It's for our future students. They might not experience that amazing night sky.
No, absolutely. Well, also, I think the students also don't understand the positioning of a telescope, or what it means to sort of track through zenith if you have an Altaz telescope.
That's true. That's true.
So it's funny you say that. So I went to Cerro Tololo not this past Christmas, the Christmas before, to use the telescope. I'm going back in July. I have for Delve. So I have 11 nights on the telescope.
Oh my God!
So excited.
That's so great.
I know. It's gonna be middle of winter, so we'll see some snow on the Andes. But, which is why I got into astronomy, of course, was to use telescopes.
Yes.
So we also, one of the big questions is, how did you become a professional astronomer? So your path through to PhD was fairly interesting, especially through biophysics.
Oh yeah. So
what took you from Minnesota to Arizona?
So initially I started with actually black holes. Because of the, my childhood, seeing this fancy buzzword like master of the universe thing, eating everything stuff. I wanted to say, when I talked with my advisor in grad school, I told to him, I want to study, I can study anything, but it should include black holes in it. And he was studying more like galaxies and black holes relationships. So I got introduced to galaxies through him. And then as more I've worked and we discovered this interesting galaxy during my PhD, now commonly refers to as Burcin's galaxy.
Yeah.
So that really changed my perspective, and I really wanted to learn more about the galaxy formation and how little we know about the galaxy formation in general. So, and when looking into details, I realize, especially the extreme regimes, captures my attentions more. So I wanted to be in more discovery-driven field, and since these small galaxies, since they are small and faint, it's hard to find them.
Yes.
So it's really, you need to use the state-of-art data, state-of-art algorithms to find them and study them. And I knew professor at University of Arizona who was doing amazing work, and I wanted to work with him. And that is how I wanted to join his group and join University of Arizona.
I love that. I love that determinism.
Yeah. You know what? There's this big conference. Every winter they do it for junior. It's an incredible opportunity for junior researchers to meet with senior researchers. So I knew that he was going to go there, and I know that he had a I had a poster presentation. He had a poster presentation. I basically look him up, find him, grab him, bring it to my poster. I told about how we discovered this galaxy, and now I want to work with him. And I knew that he was hiring, and I think he got impressed with my determinism and excitement. Later we indeed worked together.
I love that. Yeah. So you made your own destiny, essentially.
Yeah, exactly. I feel without trying, nothing happens.
No, that's true.
I tried my best.
Yeah, no, you did a great job, because it leads you here. I love that story, Burcin. I love it. And so I tell I have a 14-year-old daughter, as you know, and I tell Charlotte, you can do whatever you like in life as long as you're in control. You control your destiny. It's not me, it's not your mother, it's not anybody else. You do what you need to do to succeed.
That is true, but also I feel like that's not. There are things that beyond your control too. I feel like I got lucky too in a way that, like, I had really supportive collaboration, friends, mentors that lead me to where I am. And I also had some friends who had bad experience with their mentors, and they left the field. And I don't think that is their fault in a way, that they also wanted, but they just were not that lucky to find that good supporting mentor.
I actually love that you said that, because I think you're right. I think a lot of people see scientists that we're good at mathematics, and we're good at the field we study, and we apply to a university, and we get these lovely experiences we've talked about, and everything just falls into place. There's quite a bit of luck involved.
So much.
For most of us, actually, unless even for people like Einstein, there was a lot of luck in the way, his determination to to publish his work while he was at the patent office in Switzerland. But for people like you and I who studied this sort of science path, we had some great support along the way, as you mentioned, friends and family, mentors, a little bit of luck, sometimes support from a partner, or even a child, so your own children saying, well, should you do this, Papa, or should you do that? And it's not always obvious until you look back and think, oh, I got really lucky there. Or sometimes it can be as simple as going to the telescope and it not being cloudy.
Yeah, that's true. That's true.
I went to, and I was always reminded, I've been very lucky with observing. So I've observed on telescopes something like 1,800 nights, or like a lot. And I'm about 85% clear which is in,
Really got lucky.
very lucky, very lucky. I used to have this teddy bear from when I was a kid, and I still actually have it at the house now. And I used to take it to all the observatories, and it was sort of observing Teddy.
Oh my God.
And if observing Teddy was there, it was clear.
Oh my God, I need your bear. Can we clone your teddy bear? All the astronomers out there.
I don't think you can clone him, but I'll take him to Chile in July. But I remember doing my PhD, and I'd flown to Australia to use what was then the Anglo-Australian telescope. And I'd done all this prep work, as you said, you do all this archival work, and I did all this work to identify targets to observe and everything. And I get to the telescope, or even on the drive up to the telescope, it was raining. And I could just tell from the conditions, it was like, oh, this is not good.
Mm-hmm.
And I saw the satellite picture, there's this huge storm system. Like, oh, God. And I did my PhD in Birmingham in Great Britain. And so the voyage from Great Britain to Australia is substantial. So we do all this huge trip, we get there, and I was with my PhD supervisor, Rob Jeffries, and when we drive up the telescope, 5-6 hours, we get there, it's raining. Do all the afternoon calibrations, everything's all set up, it's raining. After dinner, we go and the sun sets, and you can hear the rain on the dome. And these big domes on the telescopes are quite noisy when it rains on them, as you know. And so we had a telescope operator called Gordon, and we called him Maverick Gordon because the way the Anglo-Australian telescope, as it was then called, the AT, it had one of these, the dome slit is like this, right? So the telescope points through it and the dome moves, as you know. But it had one of these dome slits where oftentimes the doors open like this. This had one where there was a slit for the telescope to look through, but it moved up and down, so it could be protected from the wind, from other things, dust. So what Gordon did was right near the horizon, it was clear, and you could see my stars at the start of the night through the trees are here and all the clouds, and it's raining here, but you could see my stars. So he moved the slit to here, and we observed my PhD stars through the rain. Essentially.
Oh wow!
We could hear the rain on the dome, and normally, you know yourself, you can't open the dome when it's raining.
Yeah.
But all 3 nights he opened the dome, and basically we followed holes across the sky. To find for my stars, hearing the rain, I was like, okay, we're not supposed to do this, but he let us observe.
Wow, that is.
And so I think I'm so lucky that I was able to get this data.
Very lucky, yeah. I remember one time traveling all the way to Las Campanas Observatory. I had just one night. Mm-hmm. I traveled from Arizona to Chile. And it rained.
Oh no! And that's the worst.
And then I needed to come back without any data. No. And all the time, all the money to travel there, and like disappointment because you were expecting the data and you didn't get. And in astronomy also, when you lose night, you need to get the night again. You need to apply again because they don't give you the time again because you lose because of the clouds. Yes. So you need to start from the beginning. You need to convince people that your science good so that they can give you telescope time on the telescope. Oh,
so frustrating. So just for the viewing public, just so you know, when you apply for telescope time for professional telescopes, you tend to write a proposal 6 to 9 months in advance.
Yeah.
And then so your peers, so people like Burcin and I, we will look at somebody else's proposal, decide whether the science is good enough, and then they are awarded the time. And you're not always awarded the time.
Yep, even because there's very limited time, in the year, how many days, how many nights available on a telescope, and there's so much amazing science people are doing. So even your science is great, you might not get lucky.
Might not get lucky.
Yeah.
Or even
if you get lucky, you might the clouds might.
The clouds come and get you. Yeah. Well, I think that's why they like me in the Dark Energy Survey collaboration and the Delft collaboration. Whenever I observe, it's clear. It's honestly, it's been weird. I once flew. I had telescope time in South Africa at the South African Astronomical Observatory, and it's up in the Karoo in South Africa. And I think I had 2 weeks on the 1.9 meter, which was my very first professional telescope I used. So I really like that. Beautiful telescope. Had these 14 nights. After the 14th night, I drove down to Cape Town, which is about a 5-hour drive, which you're not supposed to do. You're supposed to go to bed, obviously. But I drove down, flew to Amsterdam in the Netherlands, flew from Amsterdam to Sydney in Australia, drove up to the telescope, which again I should not really have done, and then observed all night. And by the time I'd finished that morning, I'd been awake 60 hours.
Oh my God.
So I was exhausted, but it's just like, I've got to do it. This is a super important project. And as you say, to get the telescope time is hard.
Yeah.
But I had observing Teddy, and the nights were clear. And
oh my God, I really need to find that Teddy.
take a picture and send it to you. He's looking a bit old now, but I've had him about.
Oh, so many observing nights with him. Of course, he's old a little bit.
But honestly, he's been amazing. He's so good.
Such an amazing story.
Yeah, so he could maybe sit on your shelf.
It's called bringing all my teddy bears with, see which one is the lucky one, bringing me luck.
Well, you have about 4.
Yeah, we'll like just have another luggage full of teddy bears.
That's so funny. Well, I want to go back to 2 things. One thing you said that you started in, we were interested in black holes. And you know, Joseph and I, we run this astronomy channel. Well, we are both a member of the Event Horizon Telescope. And we had this fabulous, and I know you know this well, we had this wonderful project to use 8 radio telescopes around the world, combine the data through interferometry, and take an image of the black hole, which was published in 2019. Very, very exciting.
Yes.
Of course, and one of the big deals for us was it was pretty close to the 100-year anniversary of the publication of the general relativity paper by Einstein, which changed basically all of science. I mean, arguably one of the most important science results ever. And so it's super exciting, and we're still, both Joseph and I were still involved in that project. And so this year's campaign actually is moving toward not just taking images, but real-time movies.
Oh, incredible. It is so incredible to see. You know, initially astronomy started with, you know, photographic plates. Now we have digital cameras and more fancy instruments. And now we are not only taking the static image, now we are creating these movies, even with the Rubin Observatory, right?
Yes.
It will be mapping the southern sky every 3 nights, over 10 years, creating the movies of the sky. It's not going to be only static images anymore.
Yeah, it's incredible.
Yeah. No,
you're 100% right. Incredible. So I knew you were definitely interested in that. But tell us about Burcin's galaxy.
Oh my God, yes. So I think this is again brings us to the luck part of the life journey. You know, because I was studying these black holes and galaxy relationship in my main research, and I recently published a paper. I was looking for a new project. So my team, in their observing runs, as we just mentioned, right? They had they were basically observing all these spiral galaxies. So the goal was just to nearby spiral galaxies, just image them. Yeah. But in one of those, in the background, they just see this interesting looking galaxy.
Do they see it visually or with an algorithm?
Visually, just in the background, like they were just pointing the camera. The initial images arrived, and when they just look at the images, they see it clearly. There's some weird galaxy over there. But their main goal was looking at to study the spiral galaxy, so they kept doing it, and they just take a note of that galaxy and move on, right? And then I was looking for a project, and they suggested, "Are you interested in this weird galaxy?" And I said, "Yeah, I wanna do it." And it turns out to be very interesting, extremely rare galaxy. So there is this galaxy called Higgs object. So it's so there are different types of galaxies. One of these types is just ball of stars, elliptical galaxy. So stars are just like distributed like a ball shape. And then you can also have disc-like structures, like in our own galaxy, and the spiral arms along with it. So these are the common types. In elliptical galaxies, it is rare to have a ring-like structure beyond the main body, especially if there is no connection between them. If there is a hidden disk, then you can explain because of the instabilities, it can create star formation around the body.
So would that be similar to the Pinwheel galaxy?
So it is not really, but there is a more cartwheel galaxy. If you know, it is created with two galaxies heads-on collision, right? Disturbing the main body and creating a ring structure. That is also a rare galaxy type, but it is more like clearly explained. Like it's just wild interaction creating this like weird ring-shaped structures. But there is in between the main body and the ring, there is all these anisotropies, like connection between body and the ring. But
so is that the cartwheel part?
Yeah, exactly.
Okay.
These are the things that can get created and form the ring, right? But in Hogg's object, it's just one body, like very symmetric, very round, and then this very symmetric and round blue ring. There is nothing in between, so it is hard to explain how that ring happened when elliptical galaxy stays that way.
A quick question: if it's blue, is the young star formation?
It is a young star formation, so it means that ring formed later than the main body.
Yes,
because main body is old. It is redder colors. So this Hogg's object has been there and has been puzzling a little bit. And people have been looking for similar type galaxies, like seeing similar objects like that. But although there are like handful examples, all of the other examples had like a little bit bar-like structures, like or disky structures that actually can explain the ring formation, not perfectly elliptical and symmetric like Hogg's object. Galaxy actually looked very similar to Hogg's object. No bar, no disk. But when I modeled the main body and studied in detail, it turns out to be there's another one. There's another ring in it. So there, instead of just having one elliptical body and ring, it actually has one elliptical body, two rings.
Wow.
And the rings have different colors. One is blue, one is redder. So it means probably formed in different times. But, you know, with Hogg's object, we were having hard time explaining the outer ring, just one ring. Now with this galaxy, we have to explain these two structures, which made it very challenging. We just published that sometimes, you know, in astronomy, you observe something and answer questions. Sometimes you observe something and just bring more questions.
Yes, yeah.
And that is what this galaxy was just bringing us more questions about, like galaxy formation.
Well, that's one. I love that when that happens.
Yeah. And it is also like, you know, people have been looking for this galaxy for a long time and couldn't find because they are extremely rare.
Yes.
And we just were looking for this spiral galaxy in the background. We just noticed that galaxy, and it turned out to be very interesting, another object. Yeah,
I love that. I've been reading about your object. It's actually very interesting. And what a great find. And good science to find it, by the way.
Yeah.
So I'm going to be geeky for myself here. So to find that second ring, did you model the central elliptical bulge, and then you did the image subtraction with PSF removal?
Yeah.
And so underneath it, or once the PSF removed all the stars, you saw
the hidden, very faint inner ring. So this is more like, you know, when you are outside driving a car, the sun shines through your face, right? You can no longer see where you are going.
Yes.
So what you do, you block the light, either sunglasses or with your hand. Even with your hand, if you block the light, you can actually start seeing fine details, right? In this galaxy, it's exactly like that bulge, that main body was so bright, it was overwhelming the faint structures hidden under it. So when we model it very carefully and remove that, we see that ring structure, very symmetric, very similar to the outer ring, but it is different colors. It was there.
That's phenomenal. That is really good science to do that, by the way.
Yeah, but while I am saying this as if very simple, I will also say that when we find this, we said, oh my God, probably I did something wrong, cannot be there, it shouldn't be there, why it is there. I did many times, many different models, trying to convince us it shouldn't be there. Why it is there? And finally, trying so many things, we said, okay, it is actually there.
Well, you know what? I think you just said something incredibly important. And Joseph and I last week, or a couple of weeks ago, did a video about the scientific method. And the scientific method there that you've demonstrated is you wanted to prove yourself wrong before making a strong statement about something. And that's a very important part of self-checking your work and not believing what you want to believe.
Yeah, exactly.
And that's a very hard thing to do, especially in a field like ours where when you do find something interesting, people get excited. Like the TED talk you did, you get some notoriety and some sort of quote unquote fame, and it sort of promotes your career. It would be tempting to just see something exciting and think, I'm just going to publish it. But you did the really good thing scientifically is you went back and said, what if I'm wrong? And I'm going to do some tests to show that that it wasn't wrong. There is a real physical effect there. That's a hard thing to do. That shows great academic honesty, actually.
Thank you.
No, it's very impressive. That's lovely.
I must say, like, it's also in academia, right? We have also this nice balance, check and balance structure that your peers are reading and judging your papers. So I knew that without convincing ourselves, we wouldn't convince anyone. Like it is so hard. We really didn't believe first, like it shouldn't be there. But each time, in each step, the same structure just keep appearing, and then we finally convince ourselves, like, okay, we believe it is
something big.
And we finally published, and then we got very nice reactions, and we did a little bit tiny video to share with public, and that hit Turkey, like that was shared in Turkey too, and became like people reacted very well. And then my mom called me, what did you do? Like, what's happening? And I was like, I had been talking about this for a month. Now people are talking. Now you are asking me what is going on? Oh my God. So it was so funny.
Well, and that's the beauty of things like these discoveries. It's very nice for the family.
Yeah, and general public. And then after giving the TED Talk, I received messages all around the world. Young kids, especially girls, telling me, oh, I want to discover a galaxy and name it. And, you know, that excitement is so worth it. I was thinking, whenever I am like, you know, overwhelmed and I'm like feeling down, you know, everything is always up. There's ups and downs in research. Whenever I am done, I remind myself these kids out there getting so excited with the science that we are doing.
Absolutely.
That I am saying, okay, it's all worth it.
Well, I couldn't agree more. And I think, you know, when I was growing up and becoming an astronomer, I mean, if I'm being really honest, almost every astronomer was a white man. So the children across the world didn't always see themselves represented. And so, you know, you and I talked about this earlier. I mentor a couple of children out in Washington State. Hello, Ethan. Hello, Nora. You know, so for Nora to see a female astronomer, not just sort of working in science, but excelling and being able to be a professor at an Ivy League school is very inspirational. And I think, as you just mentioned, kids want to see themselves in that position themselves. Like, could I discover a galaxy or a star or whichever discipline they go into in science? And so I think just seeing a variation of people across society is so important. Yeah, I totally agree with that. Which is when I saw your TED talk, I was like, okay, I've got to get in contact with Burcin. She's going to be a lovely, lovely guest. And you know, my daughter last year did a zero robotics course in MIT. And I think seeing someone like you is like, you're going to be so inspirational for so many kids. Thank you. Well, it's true. I mean, it really is. So I have an interesting question for you. Tell me. If money were no object or circumstance, depending on your family, would you still be an astronomer? Or if not, what would you be? To be honest, you know, you are not in astronomy for money at all. Like, it's actually the opposite. You can get so much money in an industry, maybe, like, you know, with the skills that we have.
but we stay in academia because we love science, we love exploration. I was actually a little bit worried that if I don't stay in academia, what would I do? Because I didn't want to go in industry. It was my, like, middle school Burcin, really wanting to explore the stars and sky. I was a little bit worried in my, like, when I was looking for a job and in academia, during these down parts, not up parts, in up and downs, I was a little bit worried if I don't stay in academia, I really didn't know what I would do. Probably I would stay in education, more outreach, more sharing science part type things, or studying in museum or something. I think I would do something like that if I wasn't doing professional research. But I don't think I would be in any. I cannot imagine any other job that I could do. Really, actually, in Turkey, I don't know how it is in many cultures. I guess parents want their kids to become doctors.
Oh yeah.
So when they get old, they can take care of them.
True.
My father really wanted me to doctor, and he insisted on me to at least. So in Turkey, you actually decide your major before you enter the university.
Yeah, most places do.
So it's very different than States. So he wanted me to list first medical schools, and even if I first list the physics schools first, this last option, he wanted me to add a medical school there. And I said, no, I cannot do it. Like, I can only do physics. I only want to do physics. So my list was so full of physics degrees. My father was disappointed then.
Oh, wow.
But then, when I get some discoveries, and hear my success, now they are the most proud parents out there. But like that, there was a come and go there a little bit with not going into
to be a medical doctor. Well, so you can tell your father you are a doctor.
Yeah, I'm telling him. Yeah, see, I am definitely a doctor. Not the kind that unfortunately take care of you when you're sick, but still a doctor.
Well, his daughter named a galaxy. That's pretty impressive. That's pretty cool. I love that. Well, so going back to my friend Nora, this lovely 9-year-old girl I know in Washington State, I think she would ask a very interesting question. She's got a very, very good mind. I think she would ask, why do we care about galaxies? If she's just walking down the street, who cares?
Okay. Great question, Nora.
Yeah, she's a very clever girl, so yeah.
My answer would be because we are curious. Humans are curious. I think that's the only reason. I think that's why astronomy is one of the oldest science out there. Since humans start looking up, immediately, like, where are we? Who are we?
Yes.
Where are we going? How did we come here? That was the main questions that ignite discoveries, right? All the technologies that happened just because of our curiosities, and still pushing the limits right now. I think as humans, we will always keep wondering what's out there and how we are connected to it. And that's why I am doing what I am doing. I am just curious as a human being, and I want to know how we came here, how we are going, how everything is interacting, what's out there. I just want to know. And this curiosity, we will just, by trying to answer this question, along the way, we will build technologies. That technologies will help other areas too, right? All the iPhones or all the fancy phone cameras that you guys have, It's all thanks to astronomy, right?
Absolutely.
We push limits and we are adopting those technologies to our daily life. But it all started with our curiosity.
I couldn't agree more. That's a great answer. It makes me wonder, actually, especially based on what you just said, whether people looking up at the night sky 10,000 years ago maybe seeded the first ideas of religion and philosophy.
Yeah, definitely. For sure, right? Like, that's why humans thought that sun is a god, you know, and there were so many religions all connected to the sky.
That's a good point. A lot of religions are connected to the sky.
Yeah,
that's a good point. Here's a question for you, and it's slightly off topic. What would you tell your younger self?
My younger self.
Maybe 10, 15 years ago, or even maybe as a child or a teenager, knowing what you know now and the science you know and your professorial professional career, what do you think you'd tell yourself?
I would say, just like Nora, right? She might not see so much people who are representing her, but it doesn't matter. You don't need to see people fond of you. You can be the first one, can lead the field. And I will just say, keep working hard, keep dreaming, and find people who support you, because that's the most important thing.
That is important.
While you can keep dreaming and work hard, sometimes the condition, the system might not support you, and then whatever you do, you will fail. But if you find like-minded people, the support system, then you will just flourish. And I would just tell that to my younger self.
I love that.
Yeah.
Burcin, you have so many good philosophical ideas in this. I love it. I love it. I came across the States to work at Vanderbilt University about, 23 years ago now. And I was an adjunct at Fisk University, which is an HBCU across the railway tracks there. And I have two friends from that epoch, both PhD in physics. One's Dr. Kent Wallace and the other's Helen Jackson, Dr. Jackson, and she worked for the Air Force for a long time. And they publish on Facebook, we're friends on Facebook, and I see their posts. And they often post about people from underrepresented groups who are doing something for the first time. Now, it could be whether they're a female aviator or an African American doing science for the first time, or a Muslim professor at an Ivy League school, and they publish these inspirational stories a lot, and they always title it, if it hasn't been done before, just go ahead and be the first.
Yeah.
And you said something exactly the same, and I think that is inspirational, that you don't necessarily have to either look to an idol or look to someone who is inspirational. Be your own inspiration. And if you can't find a way to do it through being inspired by somebody else, just do it yourself. And I think what you said is an absolute perfect example of that. And so your journey through, coming from Turkey, then going through biophysics, and then through your various educations in the States, and then rising to basically being the top of your field in galaxy formation, and then having a very prestigious position here, is not luck, and it's hard work on your part. And that should be the inspiration for your 10, 15-year-old self. I love that. I love it.
I will just say, it is. It sounds easy. It's not. I totally understand. That's why support system is very important. Along the way, I gave the TED Talk. I get these amazing messages from kids, but I also get these. If you look at my YouTube TED Talk YouTube comments, half of them are more than half, maybe, are questioning my identity. How can she be a scientist? In the talk, I am never talking about myself. I'm only talking about my science.
Yep.
But people are not seeing me as a scientist because of how I dress, how I believe, how I speak, and how simply how I exist, basically. And that was, seeing those comments were first very demoralizing, and I was feeling maybe I shouldn't exist, maybe I shouldn't, I will never be accepted being who I am. But then my sister again came to my rescue and said, you know what, you shouldn't even think about what people think, because these people have some people are so ignorant. They even give horrible comments about babies with different colors and say horrible things. The most basic, innocent human beings, babies, right? Even if they can say horrible things about those, then
yes,
you should you should just notice it's not about you, it's about them.
Yes.
Then I realized that's true. It's not me.
Nothing to do with
That's
you.
the problem. It's
That's
actually
right.
Then it gave me the motivation to I have the right to exist.
Absolutely.
Yeah.
Absolutely.
And hold the space in science, right? It's not about existing, but existing in the space that should be open to anyone, because science is it shouldn't be a privilege. It's such a big part of who we are, as humans, curiosity, right? The knowledge shouldn't be a privilege, and it should be open to any human who wants to learn about the universe, right?
But that's where some of that luck comes in.
Yeah.
If you're born in a sort of drought-stricken village in the middle of Africa, your chances of becoming a scientist are quite low.
Yeah.
Because of the infrastructure support, and maybe your family has to work a farm 12 hours a day. You just don't have the opportunity. Yeah. So there's a bit of luck there in sort of
definitely
where you grow up, and how whether you're rich or poor, or whether you have the opportunity to go to school even.
Yeah.
But that, unfortunately, that story that you told is sort of is awful. It makes me want to cry, actually, because you should not be defined by a faith, a gender, a national identity.
Yeah, yeah.
You're just, and I'm throwing the word "just" in there. You're just a scientist.
I just want to question, just be question, and with all these labels, I want to exist. As a scientist, as a woman, as a Muslim, as a mini immigrant. I just want to do my stuff.
You're a member of the human race. That's it.
Yeah, yeah.
I mean, if you didn't put your name on your papers, you were scientist A, and in 1,000 years' time, they looked back and said, Scientist A's galaxy, for instance, they would have zero judgment about your discovery and the intellect required to find that galaxy. It would just be, look what humanity did. How great was that? And so you see that a lot, of course. As I said, white men essentially have done really good in science the past 300 years because we of the patriarchy, because we could.
Yeah, a lot of them.
Yeah, a lot of them. And then you see, the Harvard computers and the Pickering, all those women were just these amazing scientists, but the recognition at the time just wasn't there, for instance.
Yeah.
And the foundations of modern astronomy, many of the women contributed to those.
So much.
But of course, history is not always written by equally, as you know.
Yeah, that's true.
So,
that's the problem. Even when the work is done by the incredible women, the credit generally was given to the men who were related to them. So that buried the foundation, I feel like. And I guess with encouraging next generation by doing amazing things here, we will change it, and I believe it will change. I really have high hopes, and we will be great.
Absolutely. Well, so this is the beauty. We've talked about this extensively, but the inspiration of someone like yourself succeeding, from my 14-year-old daughter, for Nora out in Washington State, for Bobby, the girl I tutor in mathematics after school, they will see this video and think, I could do that. Why not?
Why not?
I need support.
You will do even better.
Maybe.
Yeah.
Maybe they will inspire us to.
Yeah.
Yeah. I love that story. It's. Yeah. Well, there's the thing that's made me, and we don't have to get political, of course. I think it's probably best we don't. But there's a politician recently was talking about eradicating a certain civilization, and that civilization is part of the reason, one of the main reasons actually, is why there's any form of science knowledge and philosophy and medical knowledge in Europe. They basically brought knowledge back to Europe after the Dark Ages in the so-called Renaissance. almost all of it, not all of it, almost all of it came through what is now Persia, or what used to be Persia, which is now mostly Iran and Iraq. It's like the scientific knowledge that region has had over thousands upon thousands of years. You have to respect the level of just technical ingenuity they had, how well read they were. And so to sort of ever hear somebody of not wanting to sort of promote a certain civilization, it's like, hey, 500 years ago, we were desperate for that because they had all the knowledge and we didn't. So when you think of just how narrow-minded humans can be sometimes, we need shining lights like yourself to say, look, science is wonderful and for everyone, let's promote it for everyone.
Yeah.
So, oh my gosh, reading the news recently is difficult for that, just as a scientist.
That's true.
Well, let's end on a high note.
Yeah, we got a little bit depressed here.
Yeah, well, we speak honestly about things. How's that? So in 10 years' time, where do you think you'll be? Not physically, where do you think you'll be intellectually and in terms of your research?
Oh, I wanna, understand what dark matter is. This mysterious matter, right? It is dominating the universe. 80% of the matter is dark matter. We know that, but we have no idea what it is. Its nature. So I wanna. I feel like we are in the golden age of astronomy. All these amazing instruments, telescopes are coming online. We are going to map not the sky, but even create the videos of the universe. And with these observations, especially very faint and small galaxies, I feel like we will be able to finally have some understanding of dark matter. And when we understand dark matter, I feel like we will have a better understanding of how the universe is really working. So that's my goal.
Yeah.
As middle school Burcin, not ambitious at all.
And that's pretty ambitious, yeah. Well, if you can solve that, I see a Nobel Prize in the future because that's a big question.
I'm not saying like my personally, but as a scientist, as a field, I think we will get there in 10 years, and I definitely want to be part of it. Yeah.
Oh, absolutely. Well, I think you have the infrastructure set up. You have your research group. You have your expertise. I think there's no reason why that can't happen.
Yeah.
Actually.
Yeah.
So I do want to end on a super high note, and we were giggling about this before, so I want to see if I can make you laugh again.
Okay.
Is a couple of weeks ago, I officiated a wedding down on Cape Cod in Massachusetts for a friend of mine who we watched a bit of football together, a bit of soccer, and he has recently married a Turkish lady. And I officiated at the wedding. And so we talked about this earlier. I learned a little bit of Turkish, and I probably didn't do a good job. But I researched some Turkish traditions. And one of which, and we talked about this, is the bride or her family give the groom a little bit of salted coffee. And essentially that person, the groom, has to drink it without making a face.
No face.
No face. You can't sort of go, ooh. And it's to show that you are bringing fortitude to the marriage and that you'll support your wife. And that
whatever is the like how bitter things can get.
Yes.
You will never complain.
Yes,
you will
that's
still be honor your wife, and you will always support the wife.
Yes, that's right. I love this tradition. So I had there was the ring bearer was this lovely little 13-year-old girl, Penny, who was I think she's the niece of Nazle, who's the bride. And so beforehand, I bought some Starbucks coffee. It wasn't Turkish coffee. I'm sorry, I didn't have time to make it. And I put some salt in it, and I gave it to her and said, "Look, at the appropriate time, and I'll give you like a little look. Can you bring the coffee up?" And I had a little glass in my suit pocket, and I brought it out, and Nazle could see what was going on, and I poured the coffee, and she was like, "Are you?" Like, "Yep." And my friend John, who's American, he did not know this tradition. So in front of everybody, he had to drink this salted coffee, and he had no idea. And we were live streaming this to the family in Turkey. And so, of course, they all realized what was going on. And basically, everybody knew except John. And he sort of said, "John, you have to drink this coffee. I will forewarn you that your reaction to it will give some indication to your wife about the future of the marriage." And to his credit, he drank the coffee, and he didn't make any faces.
Okay.
And then I explained we explained to him afterwards what the process was, and he was very excited. So.
Yes, this is definitely one of the traditions that we love honoring.
Yes, it is really very nice. So, Burcin, I know you're busy, and we're going to wrap it up. But first of all, this was a complete privilege for me. So, you and I have worked together for many years. I did look up our publication record. We have
How many?
published 26 papers
26.
together.
Yay to us!
However, there are 26, 34. There are 8 more going through the referee process. So we could be 34 papers deep within a few months.
Oh my God! So I love it. I love it. Good job to us.
Good job to us. Well, good job to us. Yeah. But we are supported, and you reminded me of this. We are supported by this collaboration, this Delve collaboration, by maybe, I don't know how many there are, like 60 or 70 of us. There are some amazing scientists in this group.
I will say one more thing. I think this was one of the things that I was worried about becoming scientist, I think. I thought that becoming scientist will be, you have this stereotype, lab coat people in the labs, all alone, antisocial, they don't interact with people, they just lonely geniuses. So I was very worried about, but I love interacting with people and I don't want to be lonely, but I want to do science. And then realize it is the opposite. To be able to do good science, you actually need to have amazing collaborators, right? And you need to interact, you go to conferences, you present your research all the time. And at this time, especially in astronomy, if you want to discover big things like nature of dark matter, you need big telescope, big resources. So you need big collaborations. So it was just the opposite of what I was expecting. And I enjoy every second of it, like interacting with and collaborating with amazing people like you. It's such an honor. Yeah.
It is for me too. Thank you. This has been a pleasure. Thank you for your time.
Thank you so much for coming and chatting.
Yeah, no, thank you. So this has been Meet the Astronomers with Dr. Burcin Mutlu-Pakdil. I have to make sure I say that correctly. Up here in Dartmouth College on the border of New Hampshire and Vermont. Thank you so much for your time. And thank you for sharing your story. It's completely fascinating.
It was a pleasure.
Thank you very much. Yes! Yes! You're so good.